previously we managed to save up to like 65% of the cloud costs.
This is the conversation with Altil and Gergely, the founders of the service SpecOars.com. This is an open source database which shows you the price of compute resources and provide comparison between many providers, from big ones like AWS and Google Cloud to smaller ones like Hetzner. In this conversation, we figure out how they came up with the idea of such a database, how it organized technically, and how the solution was welcomed by the community. Listen to this insightful conversation and enjoy it. And if you do, don't forget to press the like button down below and leave a comment what do you think about such a solution. Welcome back to the Architecture Weekly YouTube channel. How did you guys got an idea of this thing?
Yeah, well, actually, SpecOars, I would say first iteration was developed at an edtech company. And there we used it to select the best fit instance types for machine learning based jobs. I mean, the underlying database was set up there, and it was limited to AWS, but it helped the company to reduce costs. And the idea came from there, I would say. And our goal was to set up a structure where we can ingest and present all of the pricing and the benchmarking and other instance-specific data from cloud vendors. And by doing that, we could set up a system where AWS, Microsoft Azure, Google's cloud platform, and Hetzner is supported now. So all of these providers can be compared, and we have a lot of data which is open to anyone.
Yeah, actually, if I may add some context there, and getting back to the edtech company example, I started working there in 2017, I think, and when I onboarded the team, they were looking for someone who manages the cloud infrastructure for the data science ML team. And the main problem there was that training different kind of models requires very different compute requirements. Like you need hundreds of gigabytes of RAM for training hierarchical models, or you need GPUs for NLP stuff or image processing and so on. And it's not like traditional web apps or microservices where you use bin packing with Kubernetes and you place all kind of jobs on the same node. But because of the very diverse need, it requires a very specific infra. And it was managed by some internal tools. And my goal was to standardize it and make it scalable. Managed to get Attila on board the team to help out with all the infrastructure. And the end goal was that the data scientists do not need to bother with the underlying infrastructure at all. They just start the job and the infrastructure part is handled seamlessly. So instance selection is automatic in the background. Instance is created, job is deployed, monitored, and then everything is decommissioned. So that was the actual problem we tried to solve. And then we realized that it's not only that specific team, but it's a major problem at other places as well. And as Attila mentioned, we were focusing on AWS, but realized that there are many other cloud vendors. And especially when it comes to the capacity issues, it's really good to have a much broader range of products to access. So we expand it to other vendors as well. Probably that's a longer answer than you were hoping for. Sorry for that. But
that's all right. The original problem was not originating by, like, I don't know, enormous Kubernetes cluster that would run production load, but rather by machine learning, where the demand for the resources is much higher, and thus the problem is like more visible.
Yes, exactly.
And I would like to add another aspect to that. So previously we had manually tuned parameters, like if somebody wanted to fire up a job, they would need to specify the CPU needs and the memory needs for the job. And the problem with that is that is static. So if the job changes, like with rolling out new releases, the memory usage might go up or just decrease. And the problem is there that basically years that everyone just specifies a lot of resources like CPU and RAM, or a minimum to run the current version. And if that changes, nobody takes care of that. So if there was 300 gigabytes of memory requirement, but the job now is running fine with 100 gigs, nothing will change. We will need that memory. And this system helped us to constantly monitor and adapt to those changes.
Yeah,
Okay.
basically fighting over provisioning and also reducing the chance that jobs fail because of the increasing compute needs, because we
Okay. Okay.
constantly track and scale
Oh,
automatically.
okay. Where did this request come from? So was it like CFO coming to you saying, "Hey, our cloud bill is higher than Everest," or it was like some architects, or I don't know? How did you spot the problem in the first place?
Yeah, that was an internal need for the whole data science team, which at that point was like 10 to 15 folks. And the data science team was expecting some help from the DevOps or cloud infra guys, but because things are changing so rapidly in data science and the related jobs and expectations from the business, getting outside support was rather problematic. Like, external teams just could not help us in an agile way. So we decided that we should solve this internally. So this was an internal uh, request or decision from the team itself.
Okay, so data scientists were themselves, and they decided
Yeah.
they all right. Cool. How did you decide that like you should spawn a separate company and do only that?
Yeah, that's a great question. Actually, System One, the EdTech company, previously supported us very, very generously and nicely that we can work on open source tools, and which was not core business. We managed to open source. Uh, Obviously, the direction of the development was decided by the business goals of the company. So last year, around this time, we learned about NGI Search. NGI stands for Next Generation Internet, and the NGI Search program is to support open source tools regarding internet and search and related topics. So it's an EU grant which supports open source work, and it seemed like a good fit because we are actually creating databases about cloud servers, which then later on can be searched. So we applied so that we can work on this on our own and extend to other features as well that we planned, but there were no internal business needs. So we applied, we got funded, and the grant started early January this year. And in the past 10 months, we were super happy to work on this. Well, both of us part time and also a full time front end engineer with some further help from
Okay.
external
Okay.
collaborators. Yeah.
All right. How are you gonna to monetize this?
Actually, that was part of our grant application to figure out the long term solution to support the open source development. And originally, we had some plans to build a service on the top of the collected data, and we really hope that we can get to there in a couple of months. Honestly, the open source part became much more complex than we originally hoped, so we actually spent 10 months working on ETL, spinning up the machine, creating the related infrastructure code, and so on to make everything working. So we are not there yet, but we do have plans to create a kind of container as a service solution so that if someone is looking for an optimal server, they can either go to your homepage or to your databases and find the best instance and use it in their own environment, or just provide us a credit card number and we do everything for them, including the management of the servers, the containers, monitoring, scaling, retries, alerts, and so on. So it's an additional layer of service on the top of the data that we plan to start early next year.
Okay, so you plan to either give the data to the company so that they can know what is the
Right.
best option for them, or on top, as a paid version, is like we will provision the best option for you.
Indeed.
Okay, yeah, that sounds interesting. Do you have any commercials in mind, like how much you would probably can save to a typical small company with that?
Yeah, when it comes to cost saving, to give you a real world example, previously we managed to save up to like 65% of the cloud costs. But I think the actual value of the add-on service is not even the cost saving, but you get a managed service so that you do not need an internal cloud infra DevOps team, but you get an end-to-end solution. So data scientists do not have to bother with the infrastructure at all. They just give us a Docker image, a command to run, and that's it. Everything else is handled. So I think that's a much higher value to actual businesses compared to the cost savings.
Oh, okay, okay. So it's like a solution that would be tailored to not developers, but rather data scientists and other people that require infrastructure.
Yeah, at least this is our MVP or first product in mind. Of course, later on we can extend to other markets and it could be used for traditional CI/CD tools like compiling or testing software. But our first target audience is indeed data scientists or ML
Okay,
teams.
okay. So this is what you know the best.
Yes, indeed.
All right. All right. Okay. Can you tell me how to bootstrap like a technological company on a very tight budget because the grant is not very big. So how this whole setup works for you?
Yeah, we are, I think, also learning that. Although this is my first kind of startup or technological company, previous to was absolutely bootstrapped, so even without EU funding. And this time, the EU funding actually helps quite a lot compared to bootstrapping because this is at least one external validation point that it's useful what you are working on, and you are not just bootstrapping, for a couple of years and then figure out if it's indeed useful for others or not. So it's a huge help. On the other hand, you're absolutely right that the amount of money is so we were not able to focus 100% on the project and go full time. So we had some other commitments, both Attila and myself. So that's limiting us going as fast as we wanted. Also, we have to really think about the future of SpecOars. And well, we have partly discussed that how it goes, but it puts some pressure on us. Regarding the budget, most of it was spent on HR, like paying salaries, and then also burning some money at cloud vendors and starting the machines and benchmarking those. Relatively high percentage went for legal design and UX stuff, which is super important so that we have something that's actually usable and lovable by the community, which I think paid up really, really nicely. But we do not have like a CFO or, very business oriented kind of person in the team. We are super technical and we try to keep it very, very practical when it comes to deciding what to spend on.
Okay, so it's just three people working on the project.
Yes, with some external consultants when it comes to legal, design, and UX, and a few other things. But the core team is 3 persons, yes.
Okay, that's pretty tiny, but you have already an impressive product to showcase. Okay, I wonder how you get all this data. So, is there some kind of an API that you can query for all these providers that you support to get all this data? Or
Yeah. Attila, if you don't mind, I can address this part and then I
Sure.
will pass to you regarding the infrastructure part and how we collect data from there. So, all the cloud providers usually have an API endpoint with the SKUs so that you get all the server types and so on. We are utilizing that. So, we have an ETL component called the crawler, which is calling all the supported vendors' APIs to get the list of servers. Not only the list, but we also try to get some additional information like the number of vCPUs, memory, and honestly, these APIs are super limited. So, for example, when you want to know about the local storage attached to the server, that's usually not provided via the API, or it's provided as part of the description text. So you have to do some text processing to figure out if it has an SSD or not. So we are using those. It's a lot of data cleaning and standardization as well because things are defined differently at different providers, like how they refer to CPUs, virtual cores, logical cores, if that's an actual core, and so on. So we came up with a standardized database schema and created like manual mapping how we can integrate a given vendor's machines into our database so that it becomes comparable. And once we have this list, which is actually not only servers, but we keep track of the regions, the availability zones, storage options, network prices, and a few other things. So it's like a handful of tables. Once we have that, we start our automated processes, and I will delegate to Attila to cover those so that we collect many, many more data points. Because, as mentioned previously, the API endpoints are limited and sometimes confusing as well.
Yeah, and regarding collecting the actual data from machines, we start all cloud instances one by one, and that process relies on automations to ensure accurate, up-to-date information. We constantly monitor providers' APIs, as like Gerges said, to ingest data like the regions, instances, pricing, and availability. And the whole process is built like to fill up gaps which are detected in our data set. So when it sees that there's something missing, an automated process starts and tries to fill that up. And regarding all of this process, originally we thought to start with the spot instances, which are like cheap or cheaper instances, or like compared to on-demand one, but that has become increasingly challenging due to their frequent unavailability and rapid terminations, which is a situation that has significantly worsened compared to previous years. At least that's what we can see. Starting and getting GPU-based instances are also sometimes tricky. And the worst part, I would say, was that we have faced quota issues that required weeks of correspondence with providers to secure movie CPUs, specific instance types and regions. And so that was the worst part. And due to that, we still have some missing data. We have a coverage page, and for example, Hetzner, we can cover all of their instances, so the coverage is 100%. And other providers like AWS and the like stands at around 70%. So 30% of the instances that we just can't start them and collect data from them. We have only the API data. I mean, what we can gather with the standard APIs, but not direct inspections.
Okay, so you obtain a list of possible instances, and then you spin them up to run your benchmarks to compare them from the performance perspective. How does that happen?
We use GitHub Actions, so basically everything related to these processes are open source, and not just open source, but open to anybody. You can go to our page and actually go to the GitHub pages, the GitHub repos. You can see the actual flows running. You can see the outcomes. So that is the first step. We use GitHub Actions to go over that list, which is gathered by the crawler via the cloud vendors APIs. And if that process sees there's a gap in our data, it tries to start the instance. And to overcome quota issues and not just issues, but standard procedures, like sometimes we have a quota for a given instance, but we can start it only in a given region. But it might be difficult to get that in a unified way. So what happens is that we try to start most of the instances at the given vendor in a preferred region. And if you can't start that instance in that region, we go over the list of regions. We also take into account, and it's included in our data set, the availability of that instance. So if the cloud vendor lists an instance as available in a given region, we will try that. If it's not listed in a different region, we won't try that. So yeah, we go over that list. And what happens next is that we use an infrastructure as code component called Pulumi, which is like Terraform, but they didn't invent a new language, which is Pulumi is revolving around a common API, an internal API with plugins to vendors, and they present all of the Pulumi infrastructure as code functionality to different language frontends. like you can use that from TypeScript or a lot of languages. We actually use Python because that's, well, my background is mostly related to Python, and we use Pulumi to spin the instances up. Sometimes we need to create additional resources like networks, subnets, security groups, and the like. This is all handled by Pulumi. The instance starts, it starts the data collection robot. It collects everything which is missing and pushes back to GitHub. And after all of this is done, the instance is terminated and all of the resources is cleaned up by a different job, basically destroying everything which has been created. And then a new job picks up the changes and it merges those data into our databases. And those databases, basically a SQLite file, is then published. So our APIs and I think everybody else can use the new data. So that's how the process works.
This this includes quite a few moving pieces, but at the end of the day, it's all automated. So GitHub Action is using Pulumi and all the other moving pieces, and we can sleep well at nights. And if there was a new family announced on AWS in the morning, we would see the benchmarks and the hardware inspections already, which is super nice. And we had some pretty good feedback about that from the community as well, based on the fact that after releasing a new instance family, within 24 hours, we could release even a blog post based on the automatically published results, which is, I think, pretty cool.
Yeah, that's impressive indeed. Uh, what is the biggest technical challenge you faced when implementing this whole system of spinning up the stuff with Pulumi?
What I've already mentioned, the quota, I would say that was the biggest issue. The problem here is that we are newbies. I mean, when you create a cloud account that starts from zero and you get very low quotas, you can't start expensive instance types. You can start, I don't know, 4 to 8 CPUs only, and what is this all about is ramping up. I mean, the cloud providers, AWS, for example, is prepared to see an increasing usage, and they adapt those quotas automatically. But because our use is pretty much, call it spiky, because we just start an instance and theoretically or normally we won't start it again only if there's a gap. So if we introduce a new benchmark, we will restart all of the previous instances, but only to run that new benchmark. So we pretty much failed to show that we are ramping up costs. We are ramping up using the same instances, but with ever increasing vCPU and resource sizes. And we are still struggling with that. For small providers, they are much more reachable or cooperative in this. I mean, they can fix this issue much more easily. But for large providers, hyperscalers like AWS, it's pretty tough to get access to all of the instances, and that's why we still haven't got full coverage.
All right. So basically, your usage pattern is so different from the typical corporate that they're like, what the hell is going on?
Yeah, I
Yeah.
totally understand that it looks suspicious that we do not have a lot of usage and then we spin up a server which costs more than $400 per hour with, more than 1,000 cores and like 32 terabytes of RAM. Like, why are we even needing this? And after an hour, we just switch it off. So that's understandable. Although, like Attila mentioned, this is super painful, and we have been through support at one of the larger hyperscalers like for 3 months with 15 support tickets and so on, so that we can get access to the machines, even though we are part of the NVIDIA Inception program and we got plenty of credit. So there's no risk of not paying for the usage, but still it's difficult. And just to mention a fun fact, like at one of the vendors, we actually reached a quota update request quota, which means that you cannot have more than X number of requests to increase your quota. That I found pretty funny, but I'm sure others been there as well.
All right, that's pretty rare problem to face.
And just to add to that, so that's really strengthened our thoughts about our future solution. Like seeing that all of those efforts needed to get a ramp up in those quotas is pretty much painful. And our idea, or I think our promise, and I hope you can live up to that, is that we can spare anybody who joins this service, this future service, all of these hassles, because we will struggle with that. We will try to get as much quota as we can. And as we plan to be a multi-platform solution, like we can start a new machine either at AWS or Hetzner or GCP or any kind of new vendors. If we don't have the required availability, we will just go over and look out for other services at different providers. So that is really painful, and we really hope that we can solve that and present a more pleasant flow to the user.
Yeah, it's actually not only a quota issue, but availability problem as well. So even though you got access to the quotas, but if you cannot spin up that machine in an AZ because there's no capacity, or even any AZ of a region, and you try in other ones, end up in the same situation, that's a problem. Like GPUs are in a super high demand, and in many cases, you just cannot get that machine, even with on-demand pricing. You need to use either reserved capacity or do some other kind of contracts with the vendors, which is just not viable, for example, when it comes to doing data science, because we do not need those GPUs in 24/7. We just need those for 4 hours in a week to train a specific model, and then we want to get rid of that, which is actually the promise of the cloud, right? You use the resource while you need it, and then you just give it back to others. So that's not really working for GPUs, I think, nowadays because of the huge demand. So here it's super cool to have some other providers integrated in the same way, so that if someone needs a GPU, then we will probably not try to do that within the AWS ecosystem, but we'll use a GPU specific vendor and start the machines there, which has the capacity and probably also much cheaper when it comes to compute.
Okay, got it. How do you onboard a new cloud provider?
When we started, we provided a list that we wanted to go through. And honestly, this is a manual process. We have to get familiar with their APIs and do a manual integration in our ETL framework or in the crawler. Recently, which is, I think, pretty good news for us, is that we are not just following that list, but we actually get inbound requests from vendors that they would like to be integrated in our ecosystem. They are providing support, which not only includes like credits so that we can run their resources for free, but actual technical support with the ETL integration or any other questions. So it's been great. But to answer your question short, that's a manual process which used to be several days in the past because there were a lot of unknowns. Like once you onboarded a vendor, you onboard the second one and it turns out that everything is different. You onboard the third one and only like 50% of the stuff is shared in a totally different way. Now that we have a pretty good number and growing vendors, there are less surprises. So when it comes to a pretty standard vendor, we can probably do that within a day.
Have you encountered the vendor for which there were no Pulumi support? So there were.
Yeah, that's a great question, and we decided to make that like a strict requirement to onboard a vendor, because if we want to do the direct API integrations for starting the machines as well, it's just an insane amount of work. Not actually the part when you spin up the machine and shut that down, but as Attila mentioned, Pulumi is super nice of taking care of all the related resources. So once we have our internal templates created, then we do not need to bother a lot about if a subnet is needed to be created or if we have to delete the storage after the instance has been shut down. So that's a super nice feature of Pulumi, and we decided not to do any exceptions for now. So that's
Yeah, If you think about IAC, you would think, okay, I need to spin up a virtual machine, but then you actually need a role to do that. You need a role to assign to a virtual machine. You need a network. You need a subnet. You need permissions and all that stuff. And it's 80% of the work. And the machine is just, I don't know, 5 lines of code to get it done. So yeah, I understand you well. All right, but good news for you is that vendors are coming your side and saying, "Okay, add us into the database." Right? What is their interest in being presented with your solution?
I think the recent article, the Pragmatic Engineer post, granted us some pretty good visibility, and vendors also like visibility. So being integrated in our solution helps them to get known and used by others. Also, not only from the community, but we are also seeing growing traction, for example, from Google and other search engines. So, as you know, there has been cloud comparison sites around for like at least a decade, like EC2.info, EC2 instances.info, Vantage later on, and so on. There are sites, but at least, and this is probably subjective, but what I've seen, most sites are rather limited, either when it comes to the amount of data provided, like they do the API integration, but not actually start the machines or tie to a single vendor. We try to extend our database and our info sites beyond that. And I think the search engines also appreciate it. So we are already in the first 7 to 9 search results on the search results pages. So it's there's a pretty good traction, and I think vendors are honestly interested in being part of that and being compared, especially the smaller vendors, so that they can be compared to the hyperscalers. And it turns out that their compute prices are much better. And even more when it comes to traffic prices, like all the big ones are charging you like an insane amount of money for traffic, which usually comes either for free or for super cheap when it comes to smaller vendors. So that can be a huge advantage for many use cases.
Yeah, the ingress traffic is typically pretty expensive stuff. Do you expect vendors to come up with promotions in the search results? Hey, pick us 15% off today.
Actually, we were suggested that instead of building this extra service on the top of the data, we should monetize the data itself and either, put some part of our data behind a paywall or monetize in other ways. We do not want to do that. So this data and the related ecosystem will be open source and public forever as we intend. Regarding doing like affiliations and sponsors posts and so on, I think that would result in a trust issue. Like once you go
Agree.
that route, then you cannot convince your audience that these results can be trusted and you are doing a fair comparison and standardizing in the right way. So we do not want to go that route either. And we were even thinking about just using affiliate links when you are pointing to a vendor. So not being, promoted or anything like that, or adding stars next to the name of the vendor or the server. But I think that's still a little bit shady, even though, there's no bias in the system, but still might result in a trust issue. So we decided not to try to monetize that.
Yeah, agree. That's selling yourself, right? So not the best approach, probably. Yeah, great stuff. I really like the attitude. Okay, what was the reception from the tech community? Have you received any feedback?
Yeah, it's been a pretty good ride so far. We tried to attend some in person conferences, which was actually part of the grant proposal that we have written originally, so that we try to spread the news. And we got accepted to 6 conferences in this year. It was really good to chat with potential users and others using cloud resources in person. Got some good feedback there, and online as well, we try to be active. And I've think that it's also a pretty good way to let folks know about SpecOars. So we wrote a few technical posts on our blog, and we also posted those, for example, on Reddit. And in some subreddits, there has been very good feedback, a lot of likes, and so on. For example, in AWS, when a new instance family was announced, and I mentioned that the next day we were able to easily write a blog post with the comparison to the previous generation. It got like 150 upvotes. It was in the top post
Oh,
for a week
solid.
or two. We
Yeah.
we even got some nice comments from Jeff Barr from AWS that he really enjoyed reading our post and it was nice. So I guess that's a really good feedback. And also the previously mentioned Pragmatic Engineer post got us a very good visibility. Well, obviously he has 750,000 followers, so that's very good. Visibility to our site, and the feedback was even much larger and more useful to us. Like we got 200, sorry, 2,600 likes on Twitter. I never seen something like that related to tools I've been working on in the past like 15 years. So it's been great. And not only the likes and the reshares, but actually good questions and some bug reports about some data points that we are collecting, partnership recommendations and offers, how to extend data, vendors reaching out to us, and well, that's not like the tech community feedback, but it was also useful, and we are pretty proud of that. That even big market research firms reached out to us to do a briefing and get onto the big picture of cloud-related providers. So it's been good.
Okay, I can report a bug too. So when I entered the search prompt, like a solid server to handle the database and several shards, it just put this solid server into the search bar and didn't yield any results because there are no such instance types. Okay.
Oh, got
So
it. That's the OpenAI integration, right? When you click on the search
yeah.
prompt.
Yeah.
Okay, got it. Yeah, honestly, that's a pretty lightweight feature that we did. It's a wrapper around our Open API Swagger docs, and it obviously needs some improvements. Thank you very much for the feedback. We will look into this.
Yeah, happy to help. So we already covered the perception from the small cloud providers because they are very interested in being present and being compared. So having their bit of visibility, right? But what about the big cloud providers? Do they even pay attention?
Well, Gage mentioned Jeff Barr's comments. That was pretty awesome. Other than that, I would say we are too small to be on the radar for those hyperscalers, even with our issues. Like, what was very positive is that we could actually talk to some people, like product side, and it wasn't just like firing up tickets and getting unusable responses. So that's nice. But other than that, it's still I would say a struggle with the big ones. It's very hard to get help for like our quota issues.
Yeah,
But
quotas are hard, but if I may add something, and just in the defense of the big ones, maybe we should say that they are really different because of the size of the company. Because a huge advantage is that the big ones have some kind of startup program, or like the NVIDIA Inception program that we became part of provides a very smooth and straightforward way to get like credits. So that has been a huge help for us, that we get like 10,000 or $25,000 to spin up machines and check the performance. So we do not have to spend on that. We just have to provide the software. So it's been good. With other vendors, it's like a communication iterative process of discussing how to get there. So I see a lot of advantages and disadvantages as well. But like Attila mentioned, being able to talk to someone face to face about the problem and getting support is really valuable, which is much more difficult with the big ones.
All right. The topic that is pretty interesting to me, and there are a lot of discussions on X or Twitter. Especially DHH is very vocal about that. That hey, you don't need cloud at all. Just go and run your own server, and that's not that hard that you would imagine. And don't overpay for the infrastructure and so on. So, what do you think about this, like cloud versus on-premise discussion? And what is your opinion for a typical company? What they should do from this cost perspective, let's say?
I think Attila has much, much more experience there than myself, so I will kindly ask him to provide a more detailed answer. But as an intro, I'm coming from a data science background and been working as an individual contributor, manager of small teams, and so on. But cloud is great for ML teams because mentioned at the beginning we have very diverse need for different jobs and we need GPUs for a couple hours a day or a week, but then we do not need that. So having your own servers just sitting around doesn't make a lot of sense for this kind of load. Although like 10 years ago I was consulting a big Fortune 1000 company and they had like supercomputers sitting around so that the data science team can run a job once a month for 15 minutes. The cloud is a great solution for these kind of problems and not to have, server sitting in the cellar or something like that. But Attila, I will pass to you with a more general view on this scene and not limited to DS.
I'm coming from big big company environments, those mostly on the train of having those big data centers with a lot of servers on premise. And as I've seen most of the costs related to those, yeah, just getting a server and putting that into a rack seems to be a cheap process, but there are a lot of additional costs, like running a data center. If you have your own, there are a lot of additional costs. If you don't have your own, you have to pay for someone building, designing, and doing that. Still, I would say the hyperscalers compared to running a small-ish setup in your data center or in just your office. Of course, that's much more cheaper, or can be much more cheaper than having anything in the cloud. But I would say the difference is not just in the costs, but in the flexibility. Like your average cloud vendor can be managed with great tools like Terraform and Pulumi that can spare a lot of time um, uh, building infrastructure, cloning infrastructure. Like if you want to have, I don't know, a new development cluster from something, if you have the right tools set up, it's just a matter of some clicks or some comments. While if you have your own on-premise solution, of course you can build the same, but that's much more difficult. And even though you have the same ish thing on premise, which you can get from like AWS on the infrastructure side, like virtual networks or virtual instances in your resource pool. Cloud vendors provide a lot of advanced features, a lot of additional services like storing secrets, getting them, having databases. So I would say it really depends on your case. Sometimes it definitely makes sense to have your own data center, your own machines, or in a hosted data center, or just buy a virtual private server. That's completely fine, or just set up that locally so your internal clients can do that. So that really depends on the exact architecture. What I would like to add and close this thought is that there are a lot of people I can see, and that's again the quota issue. They seem to think that the cloud is an endless field of infinite resources, but it's not. You have to prepare for that, but still a good account, like you have everything set up, you have the financial requirements and the like, it's still much more easier to scale up and down. And I would say from the cost-wise and the infrastructure side, that's the main differentiator. If you have a workload which can scale like on demand with the demand, the cloud solution might be much more better.
Thank you, Attila. And if I may refer to your related topic, which came up quite a few times, it's like using SaaS, software as a service solutions versus like hosting your own solutions. And both Attila and myself are coming from Eastern Europe. And when I moved to the States, it was pretty weird to see that folks are using SaaS solutions for super basic stuff like managed databases. Like you could just do that at the fraction of the price of the service. Like you can spin up the machines, you can create a cluster, you can manage it. Why would I want to pay for the service provider for that? And I understood the very different background. Like when where I was coming from with my bootstrap startup in Eastern Europe, we had more skills than money, and we managed things for our own, which had the advantage of, we actually learned how to run those open source tools and stuff. But I totally understand that startups who has some capital, it makes much more sense for them to outsource a lot of things and rather pay a little bit extra instead of having like DBAs in the startup team and take care of those by paying a little bit of extra. So I think it really depends where you are and your background, and probably the cloud versus rented dedicated servers versus on-premise physical servers you are managing. And that really depends on the location, the team, and like business requirements and SLAs and scalability and all these kind of stuff. So I think most makes sense. But yeah, I totally get like what you mean on Twitter. All these crazy serverless function costs and all the other scary things are raising this issue that folks should really think about what's the best solution for their problem.
Yeah, exactly. So that's the trade-off you have, right? So you can pay for the solution and not have an engineer who is really proficient in, I don't know, managing databases, for example. Or if you have such an engineer, you can save this cost and set up it all manually. The problem is the speed, right? So if you're like in the search of a product market fit, then you would better to experiment and to try different ideas very fast and then find quickly what actually sticks, and then put all the efforts and then evaluate what exactly the setup you want for your company, and only then make those calls.
Right.
Yeah, with Lambda it's the same stuff, right? Of course you can buy a server or buy a virtual machine and deploy everything together all together there. But if there's no real usage and you're still experimenting and there are like 3 requests per month while you're trying it all out, like why are you paying for the servers? Then doesn't make any sense. So yeah.
Exactly.
Yeah,
Hey,
but I would say so. Sometimes, or most of the times, you might need a fraction and a fraction of an engineer for running clouds. I mean, yeah, it might be a much more easier task for him or them to 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 solve that task, but the cloud doesn't run by itself. So expertise and the capability of understanding how things work really help in setting up cloud environments. So yeah, you might spare some FTEs if you have a larger team, but you still need most of those guys, I would say.
yeah, the cloud is not like a magic wand where you say, okay, I need those virtual machines and a database, give it to me. It still is subject to configuration and setting the virtual networks and the IAM roles and making it all work together and figuring out how to deploy it properly and how do you recreate the same infrastructure on your staging environment, like desirably as the same as your production environment and so on. So yeah, that still requires cloud expertise, let's say. All right, so we're running out of time. Let's talk about the next major milestones for SpecOars. What do you expect to get in, I don't know, next 6 months?
Yeah, there's a technical aspect of that. We are in the process of onboarding new vendors. So that's I think ongoing for some time. Also, new benchmarks. We have added some application specific benchmarks like Redis or static web serving, and there will be quite a lot of others. As part of the NVIDIA Inception program, we try to focus more on GPUs and ML specific jobs like LLM inference speed and doing some other ML model training kind of workloads. Attila have been looking into some GPU related benchmarks, and if time allows, we can get into the complexity of like running Kotless and figuring out what makes sense and what not. So that's the technical part. Regarding the business aspect, the grant is ending by the end of the year, and we have some extra budget to run it in the next quarter. But if we want to keep the momentum and focus on this at least part time, if not full time, then we have to figure out the business aspect as well. Honestly, we are currently fundraising a pre-seed so that we can take SpecOars to the next step, and we can both go full time on this project and give up our other commitments and grow much faster. That includes the container as a service for data science ML teams that we briefly discussed previously, which I think get us to a track that we have like a long-term goal and actually be achievable goal with SpecOars. And super long term, I really like to think about SpecOars as a general solution when it comes to any kind of compute. So now we are focusing on cloud servers, but we could open this up like from the community responded to our post with serverless functions. Like there are plenty, and there's no way to compare how those perform looking into databases and so on. So I really hope that we can get there. It's a very long-term vision, and there will be quite a few bumps until we get there, but that's my take on it. Attila, anything to add?
Well, pretty well said, I would say.
Okay, cool.
Yeah, serverless was one thing that I was thinking about, like measuring how Azure functions compared to Lambda, compared to other offerings from other providers. Yeah, that would be nice to see. Thank you very much for the interesting discussion. That was very enjoyable. Yeah.
Vladimir, it was our pleasure. Thank you very much for the super cool topics. I really enjoyed having this discussion with you too, so I highly appreciate it. Thank you very much.
Yeah, thank you
Thank you
very
for
much.
having us.
Yeah.